Welcome back to the Deep Dive. Today, we are really getting into the weeds on a tough topic.
Yeah.
How do psychologists actually study something like prejudice and discrimination? It's slippery, often hidden. You told us you want that structured knowledge. So we're aiming to deliver the sort of scientific blueprint researchers use here.
And it really is a challenge. I mean, it's not like measuring, say, temperature. Studying human thought, especially bias, that takes some real ingenuity. But the goal really boils down to maybe four things. First, figuring out the causes, what makes people think or act with prejudice.
Okay, the causes.
Second, understanding what limits that behavior. Third, testing the theories we have about it rigorously. And finally, and this is the crucial bit, using those validated theories to actually design interventions that work. Things that can reduce prejudice in the real world.
Right, that's the payoff. Okay, so let's unpack that blueprint. How does it even start? How does a research idea get formalized?
Well, it can start pretty broad, actually. Observations from daily life, someone sees something happening, or maybe checking if an existing anti-bias program is actually doing what it claims. But often, the most solid starting point is existing theory. Established theories.
Theories is the foundation.
Exactly. They're the organizers. They take what we know or think we know and propose links between concepts. We need some basic terms here. So first, a variable. That's just anything people differ on. Prejudice itself is a variable. Height is a variable. Anything that varies.
Got it. Variable, the thing we're interested in.
Pretty much. Now, the theory uses postulates to organize these variables. Postulates are like the fundamental rules or assumptions the theory makes. Think if-then statements. And from those postulates, we derive a hypothesis. That's the specific, testable relationship between variables we actually investigate in a study.
Okay, hold on. Let me see if I've got this hierarchy right for everyone listening. Theory, big idea. Postulate the if-then rule within the theory. Hypothesis, the very specific sentence we can test. Is that about right?
That's a great way to put it. Exactly. Let's make it concrete. Take sociocultural theory. A core postulate might be prejudice is learned from social norms. So a testable hypothesis flowing from that could be racial prejudice levels will be higher in places where social norms openly support that prejudice.
Makes sense. Or what about intergroup relations theory? That one sounds a bit different.
It is. It has more of an economic or resource focus. Its postulate might be competition between groups for resources leads to dislike of the outgroup. So the hypothesis you'd test is prejudice is stronger when groups are competing versus when they're cooperating.
Okay, so we have these hypotheses derived from theories, but they still sound a bit abstract. Prejudice, competition. How do you measure that?
Ah, you've hit the nail on the head. That's the core challenge, measurement. We study hypothetical constructs. These are abstract ideas like empathy, prejudice, self-esteem. You can't directly point to them or, put them on a scale. So we create operational definitions.
The translation layer, making the abstract concrete.
Exactly that. An operational definition is the specific, observable, measurable way we represent that abstract construct in this particular study. And here's a key point. Almost any construct can be operationally defined in multiple ways. There's no single right way. Then this operational definition lets us restate the hypothesis as a specific prediction.
Right. So you're turning theory speak into lab speak. If my hypothesis was people high in empathy are more likely to help, the prediction becomes something like people who score higher on the specific empathy questionnaire, say the Davis scale, will donate more money in this specific simulated charity scenario.
Precisely. You've defined empathy as a score on that scale and helping as the amount donated in that context. That jump from abstract hypothesis to concrete prediction is absolutely fundamental.
Okay, so now we have our measures, which are basically these operational definitions we've chosen. How do we know if they're any good? Are they scientifically sound?
Good question. We evaluate them using two main criteria: reliability and validity. Reliability is all about consistency. Does the measure give you pretty much the same result if you use it again with the same person, assuming the trait itself hasn't changed? If it bounces around wildly, it's useless. It's just noise.
Okay, consistency makes sense. And validity.
Validity is about accuracy, but it's a bit more than that. It's about measuring the right thing. Does it actually assess the characteristic it's supposed to assess? Does it capture all the important aspects of that characteristic? And crucially, does it measure only that characteristic, not something else mixed in?
But that something else, that feels like the big problem in prejudice research, right? This thing called Social Desirability Response Bias, people wanting to look good.
Exactly. It's a major threat to validity, especially with self-reports. If someone holds prejudiced views but knows that's not socially acceptable.
Hmm.
They might give the right answer on a questionnaire, not their true answer. That bias absolutely reduces the accuracy, the validity of the measure.
So how do researchers deal with that? You can't just trust what people say then.
Well, it means you absolutely cannot rely on just one type of measure. You need a toolkit.
Hmm.
This brings us to the main ways we try to assess prejudice. There are sort of three big categories.
Okay, let's break them down. What's the first one? The most obvious, maybe.
The most obvious is A, self-report measures, the ask method. Just asking people directly about their attitudes, opinions, behaviors. It's the most common approach. We can use things like checklists for stereotypes. Is this group lazy, intelligent, or probability ratings? How likely is a member of group X to have this trait? For behavior, there's the classic social distance scale, asking how willing you are to associate with a group, from marriage all the way down to excluding them from the country.
The big advantage seems to be efficiency, right? Easy to give to lots of people, cover lots of topics quickly, find out opinions directly.
Definitely efficient. But the limitation, as we just discussed, is that huge vulnerability to social desirability. People can hide their true feelings pretty easily. Researchers try to mitigate this maybe with anonymity, promising confidentiality, or by using other types of measures entirely.
Okay, so if asking directly is flawed, what's next?
We try to bypass the conscious mind, go straight to the body's reactions. B, physiological measures and neuroscience, the react method. Here, we're looking at involuntary physical changes.
Like heart rate, maybe blood pressure, even tiny changes in voice pitch. Or the big one, brain imaging with fMRI.
Exactly. The appeal is that most of these responses are outside of conscious control. You can't just decide not to sweat or have your heart race when you see something that triggers a reaction. It can also indicate the intensity of the reaction.
And neuroscience, particularly looking at the amygdala, seems to have offered some really interesting, though maybe complicated findings.
Very interesting, yes. The amygdala is often linked to threat detection, emotion processing, and early studies often found more amygdala activity in white participants when they viewed pictures of black faces compared to white faces.
Right, which sounds like a straightforward prejudice center finding. But then the research added some really important twists, didn't it?
Crucial twists. It turns out it's not so simple. Later studies found, for instance, that the amygdala also reacted more strongly to dark-skinned white faces. And really importantly, that increased activity wasn't found when the pictures were of well-liked, famous black individuals.
Wow. Okay, so that really complicates the story. It suggests the amygdala isn't just firing based on race category alone. Maybe it's about perceived threat or unfamiliarity or negative associations tied to certain features, not just race itself. That's a huge nuance.
It absolutely is. It shows how careful we have to be with interpretation. But even these physiological measures have downsides. fMRI is incredibly expensive, for one. And a big limitation is distinguishing specific emotions. Your heart rate spikes is that fear, anger, surprise, intense interest. The physiological signal often just tells us intensity, not the specific flavor of the emotion.
Okay, so self-reports can be faked, physiological measures are hard to fake but expensive, and maybe emotionally blunt. Is there a middle ground?
There is, and it's become very influential. C, implicit cognition measures, the associate method. These try to get at the automatic involuntary associations you've stored in your memory between concepts. Like, how strongly is fat linked to unpleasant in your mind, even if you'd never say that out loud?
And the main tool here is the IAT, right? The implicit association test. How does that actually work?
The IAT is clever. It works by measuring something called response competition. It basically pits your automatic habitual reaction against a more controlled required response. Imagine you have a strong unconscious negative association between, say, old people and bad. The test forces you to pair old people with good words very quickly. If that automatic old people bad link is strong, it will interfere and slow you down when you're forced to make the opposite pairing, old people good. That tiny difference in reaction time is the measure of your implicit bias.
So the advantage is much harder to consciously control or fake your split-second reaction times. Less social desirability bias.
Much lower likelihood, yes. But it also has limitations. A key one is that the IAT really only shows that one concept is more positively evaluated than another, relative to each other. It doesn't tell you your absolute level of prejudice. It's a comparison score.
Which might explain something I've heard, that scores on self-report questionnaires often don't correlate very highly with scores on these implicit or physiological measures.
Exactly. And the reason is probably that they're measuring different things. Self-report taps into your conscious, controlled beliefs and attitudes, what you think you believe. or what you want others to think you believe. Implicit and physiological measures. They're tapping into more automatic, perhaps less conscious gut-level associations and reactions.
So it's not that one is right and the other is wrong.
Not necessarily. It highlights why using multiple measures is so crucial. The strengths of one method can help offset the weaknesses of another, and maybe more importantly, measuring both the controllable and the less controllable aspects gives you a richer picture. These different aspects might relate to different kinds of prejudiced behavior in the real world.
Okay, that makes a lot of sense. So once we have our measures sorted, hopefully reliable and valid ones, what's the overall strategy? How do we actually conduct the research to find relationships or even causes?
Right, we need a research strategy. There are several, but let's start with perhaps the most common one for identifying relationships: correlational studies.
This is where you measure two or more variables as they naturally exist and just see if they're related, right? Like sending out a survey.
Exactly. You measure variable X, you measure variable Y, and you see if they go together. We use a statistic called the correlation coefficient. Usually written as RR, tells you two things: the strength of the relationship, from -1 to +1, where numbers closer to 1 or -1 means stronger links, and the direction. Positive means they go up and down together, negative means one goes up as the other goes down.
But here's the big caveat you always hear, isn't it? Correlation does not equal causation.
The golden rule. Absolutely critical. Correlational research by itself cannot tell you if one variable causes the other. It only tells you they're related. To show causation that X causes Y, you need to meet three conditions. Remember them.
Let's see. One, covariation X and Y have to actually be related. That's what correlation gives you.
Correct.
Two, time precedence X has to happen before Y. The cause must precede the effect. And three, no alternative explanations you have to rule out other potential causes, other Z variables that might be responsible for the relationship.
Perfect. Correlational studies often can't satisfy those last two conditions. You don't know which came first, and there could always be some other unmeasured factor involved. That's why if you want to talk about causes, you generally need to turn to experiments.
Right, the controlled setting. This is where researchers actively do something.
Precisely. Experiments are specifically designed to meet those three criteria for causality. The key is manipulation. The researcher manipulates the independent variable, the thing they think is the cause, and then measures the dependent variable, the thing they think is the effect, to see if the manipulation made a difference.
And you could do this in a tightly controlled laboratory experiment, maybe sacrificing some real-world feel for that control.
Right, high control, but potentially high artificiality. Or you can do a field experiment out in a more natural setting that gives you more naturalism, maybe less precise control. But here's a vital point about experiments. You can only draw causal conclusions about the variable you actually manipulated. You can't make causal claims about things you just measured, like personality traits or pre-existing attitudes, because you didn't randomly assign people to have those traits.
Got it. So experiments are key for causation. Are there other strategies researchers use to build the overall picture?
Yes, definitely. There's ethnographic studies, which often use qualitative methods observation, interviews really diving deep into a specific context, understanding things from the participant's own perspective, very rich, detailed data. There's also content analysis, where researchers systematically analyze products people create, like texts, documents, advertisements, photos, to identify recurring themes or patterns related to prejudice.
And then there's the big one that combines lots of studies, meta-analysis.
Right. Meta-analysis is a statistical technique. You gather all the studies you can find on a specific relationship, say the link between intergroup contact and prejudice reduction, and you statistically average their results. The logic is twofold. First, the average result across, say, 50 studies is likely a more accurate estimate than any single study. Second, the quirks and limitations of individual studies tend to cancel each other out when you average them.
So it sounds like the real confidence comes not from one perfect study, because that probably doesn't exist.
Unlikely, yes.
But when you see findings converging, when studies using different measures, self-report, implicit, physiological, and different strategies, correlational, experimental, ethnographic, all start pointing towards a similar conclusion.
That's exactly it. That convergence across methods and strategies gives us the strongest confidence. If the findings consistently support the hypotheses derived from a theory, our confidence in that theory grows. We might then feel ready to apply it, perhaps to design interventions. But if the results were inconsistent or contradict the hypotheses, then the theory itself needs to be revisited, revised, maybe even discarded.
And how do researchers make sure a finding isn't just a one-off, a fluke, of their particular setup.
Through replication, repeating the study. Sometimes it's an exact replication, trying to do it precisely the same way. Other times it's a conceptual replication, where you test the same basic idea but maybe change the specific procedures, measures, or populations slightly. The goal of all this is generalizability. Do the findings hold up across different people, different situations, different ways of measuring the concepts? If they do, they're much more powerful.
This has been a really clarifying deep dive. We've gone from abstract theories about prejudice down through the nitty-gritty of defining and measuring it, wrestled with that social desirability bias, and navigated the crucial difference between just finding a relationship and actually proving a cause.
It's a complex process, definitely. And perhaps the biggest takeaway for you, the listener, to think about is that finding we discussed, the low correlation between controllable self-report measures and those more automatic, implicit, or physiological ones. It strongly suggests prejudice isn't just one thing. It seems to exist on different levels, related to different kinds of behavior, the deliberate actions versus the gut reactions. So the provocative question that leaves us with is, what does this duality mean for designing effective ways to reduce prejudice? Should interventions focus mainly on helping people control their outward behavior, the things they say or consciously do? Or do we need to find ways to change those deeper, automatic, habitual associations that still show up on things like the IAT? Where should the effort go?
That's a really fundamental challenge to consider. Thank you for joining us on this deep dive into the science behind studying prejudice. Keep exploring.